of the pilot spool?
From CCU.
What is the set point in the FIVA valve used for? Not timing. No. What is the set point?
Is set point the center neutral?
Not quite. Not load, not exhaust temperature. Okay. How do we know where the FIVA valve is? How do we know where the main spool is?
The feedback sensor.
The feedback sensor. And the feedback sensor does what?
Measures the position of the spool.
Yep, and sends the position to the control system, yeah, the CCU. Yes?
Yes.
Right. So we know where the FIVA is. How do we move the FIVA? How do we get the main spool to move? We're talking system, not oil pressure now. We're talking about the system. So we have a signal from the FIVA to the CCU. And then how do we get the FIVA to move?
When there comes a signal from the CCU that we need to do an operation.
Yes, so the pilot valve via signal from the control system, yes? How does the pilot valve signal, the control signal to the pilot valve, how does it know where to move the main spool, where to move the FIVA?
The TACO will send the RPM. What is the present RPM?
Yeah, but we're still focusing on the FIVA. The set point. The set point is the position the FIVA has to be in at any point in time. Can you remember the three positions, the three channels we looked at yesterday? FIVA set point, FIVA control signal, FIVA feedback. Those three are your FIVA loop. The set point is the system generated signal to say this is where the FIVA has to be at this speed, this load, at this point in time. The control signal is sent from the CCU to the pilot valve to move the FIVA in the position that matches the set point. Then the feedback is the signal back to the control system, and that matches the set point movement. Okay. So yes, the TACO signal is important because, of course, of the timing for the injection and the exhaust for operation. That is right, but we were just focusing on the signals for the FIVA. Yeah. Excuse me. So the FIVA operation, the principle is the same for the NABTESCO The difference is the feedback sensor and the control or the pilot spool. Sorry, the pilot valve is of a different make. Okay. The FIVA from the Bosch Rexroth, we have a main spool and we have these ports that have to be open and closed, but instead of using the pressure port to give us the control oil and the exhaust valve, sorry, the working pressure over here, we use, or Bosch use, the principle of the pressure being on the top side of the spool to move it up and down. So you have a signal to the control valve, opening and closing port A or B to move the main spool up and down. And then we have a feedback sensor giving a direct signal back to the pilot valve. Therefore, we have this, it's called a self-controlling valve. So there's no set point for position. It is getting its signal back from itself, so it knows where it is. It's a self-controlling. Okay. No questions? The movement is still the same. We still need to do a prepare to inject, synchronize to inject, prepare to open, synchronize to open, prepare to close, and synchronize to close the exhaust valve. We still need to have a nice fluid movement of our main spool, and we're still going to be in the center position, so we're draining both the booster and the exhaust valve actuator. Then we're going to be, of course, in this position, still draining from the booster, but then we're going to do an exhaust valve operation, and the same for the fuel injection, draining here and then do the fuel injection. We are only able to do one of the operations due to the fact that it is one valve. On the newer engines, we will be looking at a FIVA, sorry, an LFI and LVA. So instead of for one valve doing two tasks, we split the valve up. So now we have this electronically controlled fuel injection valve, LFI, and electronically controlled valve actuation valve, LVA. This is so the accuracy and the control is more accurate on the larger bore engines. We're talking about the G engines, ones with the huge stroke there. So we have the accuracy there. Okay. The signals to and from the FIVA valve itself are used to safeguard the system. So we see here that we have the CCU, and then we can have a fuel signal, sorry, a control signal with regards to the position of the crank for this specific unit. And then we have the signal to the FIVA shown here, where we have a movement of our main spool and then a signal back to the CCU to say that the FIVA has moved in that specific position. And then it will do the same cycle, check and correct, check and correct, check and move, move and check every half a millisecond to ensure that we are having this main spool in the correct position at all times. So that is channel 30. And then we have also here, we can see a second feedback signal from the fuel booster, channel 31. So then we have the two signals, 1 and 2, to give us this safe position of the exhaust of the FIVA valve if there is a problem. Signal 1, channel 30. If the FIVA feedback signal is not valid, i.e. outside 40 to 20 milliamps, we have used this 40 to 20 milliamps signal strength and range, so we know that we have a functioning FIVA feedback. If it's outside 40 to 20 milliamps, that means that we have a feedback failure. Therefore, the system doesn't know where the FIVA is. So therefore, it will force the FIVA into this safe position, which is fully down, exhaust valve fully open, zero fuel injection. If the FIVA valve feedback signal is indicating a too high speed, i.e. this is not possible, again, feedback failure, it will then again force the main spool into the down position, cutting the fuel and opening the exhaust valve. if the feedback signal is around the position just outside TDC, so there is